Hello friends, welcome to the Coding Interviews channel. Hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. I have created several playlists to cover various categories of problems such as stacks, queues, linked lists, dynamic programming, BFS, DFS, and so on. Please check them out. I have uploaded the code for this problem to the GitHub repository. You can get the link from description section of this video below. Let's jump into today's problem. Sort colors. Given an array with n objects, color red, white or blue, sort them in place so that objects of the same color are adjacent with the colors in their ordered red, white and blue. So basically there are given n objects in an array, red, white and blue, and we have to sort them together. Basically all reds should be together, white should be next and blue should be next, right? So here we will use the integers 0, 1 and 2 to represent the colors red, white and blue respectively, right? And note is given, you are not supposed to use the library sort function for this problem, right? So we are not allowed to use any inbuilt sort in any of the languages that is there, right? So basically we are given with an array of zeros, ones and twos, right? And we have to group together. All zeros should come first and then all ones should come next and all twos should come at the last, right? So that's what we are supposed to do, right? So one simple approach will be, we go through the entire array, right? So let's say for example this is the array, right? 0 1 2 0 1 2, and finally what we want to see is 0 0 1 1 2 2. So this is what we want to see as, right, as the output basically. So what we are going to do is, we will go through the array and simply count the number of zeros, ones and twos, right? So in order to count, we will have a counts array where 0th index will be counting number of zeros, first index will be counting number of ones, second index will be counting number of twos, right? So once we go through the array, right, this one, the counts array will be 2 2 2, right? So now we will use this counts array to refill the array back. So there are 2 zeros and there are 2 ones and there are 2 twos, so we will just fill that and that is the answer. So this is one of the simple approaches that we could use and get away with it. So we will have to go through the entire array first, and in the second pass we are going to look at filling up the array, right? So that's how we are going to proceed for the this approach. So we will go and look at the approach 2 also. Let's go ahead and look at the code for this problem and for this approach 1, and then come back and look at the approach 2, right? So just a bit, right? So we have counts array which is of length 3, because we only have 3 things to be counted, right? Zeros, ones and twos. So first we are going through the entire array and doing the counts, right? So once you go through the counts, you have them and initialize the j, the counts index, index array, this one, initialize to j. So as long as the count at that particular j is greater than 0, right, we will put that particular element into that particular index, right. So we go through that entire array one more time and fill up that array. Finally that is the output for us, right. So this will be a pretty simple algorithm, and if you look at the time complexity for this, right, we are going through the entire array assuming that the length of the nums is n, right. So there is order of n for this for loop and there is order of n for this for loop. So that means it will be taking order of 2n, right, order of n plus order of n. Since we do not care about the constants in big O notation, we will say the final complexity is still order of n. And if you go look at the space complexity, right, all we are using is an array of length 3, right. So this is just a length of 3, irrespective of the length of the nums, we just use only array of length 3. That means we can say this is a constant space that we are using, right. So that means we will say space is a constant. So time is order of n, space is constant for this first approach. So let's go jump into the second approach, which will be more interesting, where we don't actually count and refill the array, right. So the idea that we are trying to do here is cluster all zeros, ones and twos together, right. So we will have all zeros first, all ones next and all twos the last. So that's the organization for our final output, right. So from that thought, we can say that zeros should start at 0th index in the array, right? So if there are any zeros in the given input, it should start at 0th index in the array, right? So that's a good assumption, right? And if there are no zeros, that means ones should start at 0th index, right? So what I am saying is, if there are any zeros in the input, then that 0 should start in the output basically, right? So this is for the output. For output, right? So 0 should start at 0th index in the array, right? But if there are no zeros, ones should start at 0th index in the array, right? That's what we are formalizing, right? And one more thing that what we are formalizing is 2's should end at n minus 1th index in the array, right? That is for the output. So if there are any 2's that are present, they should end at n minus 1th index. So these are the three things that we are going to keep in mind. So from this thing, right, we are saying 0 is starting at 0 and ending at some index, and 1 is starting at some index and ending at some plus some index, right? We don't know what that index is. And 2 should start at another index and end at n minus 1th index. So what we know here for sure is, assuming that the input has zeros, ones and 2's, zeros should start at 0th index and 2's should end at n minus 1th index, right? So that's what the approach or the assumptions that we make and go from there, right? So for that purpose, what we are saying is, okay, I am going to declare the first position, 0th position is 0, right? And from this theory, initially I am assuming there are no ones, that's why I am declaring first one position also 0, but 2's position is n minus 1, that's what we are declaring, because the last number should be n minus 1, sorry 2, right? That's what we are going to do. So while we go through the elements in the array, we will adjust these pointers, right? So our goal is to put all zeros to the start of the list and all 2's to the end of the list and all ones in the middle of the list, right? So that's the thing. So when we encounter a 1, we don't have to do anything, but when we encounter a 0, we have to move that. That means we have to swap it. When we encounter a 2, we have to swap it. So when you encounter 1, we don't do anything, but when you encounter a 0 or 2, you swap it. But how are you going to swap it? Use these things. So when you encounter a 0, you swap it with the next 0's position. When you encounter a 2, you swap it with the element which is present in next 2's position. That's what the logic that we are going to use. But when you see a 1, there is no need to do anything. So that's a simple logic that we are going to use. So let's go ahead and look at the code for this approach, right? So I am assuming n is the num's length, the length of the input array. Initialize 0 for the 0's position and 1's position also 0, 2's position is n minus 1, right? This is what we assumed, right? And now we are going to go through the entire array starting from 0 to n minus 1. So 0 is being initialized for next one position, right? So while next one position is less than or equal to next two position, we will be in this while loop. What we said, when we see 0, we are going to swap it. When we see 2, we are going to swap it. But when we see 1, we are not doing anything. We are just incrementing the index, right? Right. Let's go and look what actually we are doing in the swapping, right? So next 0's position, we are getting the into temp and putting 0 instead of next nums of next 0's position, you can have 0 as well, it does not matter, right? So in the case of this, you can directly say this one, it does not matter, because what you are inserting is essentially 0, right? So put 0 into the next 0's position and put the temp into the next one position, right? And then increment the 0 and 1 positions, because in the 0th position we already filled out with a 0. So that means the next plus 1 position will be next 0 that you want to insert, right. Similarly, the same thing we will apply for next 2's position, right. So, whatever we are getting in the next 1 position, we put into the temp, and whatever we have in the next 2's position, we are putting into the next 1 position, and then replacing that with the temp. Basically, we are trying to swap, right, whatever is there between the next 0's position with next 1 position, and whatever is there with next 1 position with next 2's position. But when the value at next 1 position is 1, we do not have to do anything, because once we want them to be in the middle, right. So, that is how we are able to solve this particular problem. So, if you look at the time and space complexity for this, right. So, we are saying n is the num's length. So, we are going through the while loop, right, we are going through the while loop, right. So, from 0 to n, right. So, that means this will be a order of n time, right, and when you look at the space complexity, right, it will be constant time. So, we are only using these 4 different variables irrespective of the length of the input, right. So, we will say the time complexity is order of n and space complexity is order of 1. So, if you try compare the time and space complexities between 1 and 2, the approaches 1 and 2, right. So, there is no big difference overall, right. So, in the first approach also we said the time complexity is order of n, and in the second approach also we are saying the time complexity is order of n. The only difference here is we are going through 2 times in the first approach, right. We are going through the array 2 times, one is to count and second time is to fill the array. But whereas in the second approach we just go through the array only 1 time, right. So, that is the only difference, but the overall time and space complexity there is not much big difference, right. So, that we can see from these numbers, time complexity is order of n and space complexity is order of 1 in both of the approaches. If you have any further questions, please post them in the comment section below this video. I will get back to you as soon as I can. I have posted this code to the GitHub repository. You can find the link in the description section of this video below. If you haven't subscribed to the channel yet, please go ahead and subscribe and also share among your friends. Please click on the bell icon so that you will be notified about my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.